Hey, welcome back, Basic Algebra 2 kiddos. Today we are going to start section 7.2. 7.2 looks at a lot of different properties, and for today's lesson we are just going to focus on two. We're looking at properties of radicals. And so what that means is as we're working through problems today, we will have our problems in that radical form versus rational exponents. Now, the first property is called a product property, and this one is like my favorite. I think it's so cool. So this shows us that, let's say I am multiplying two things that have the same root. So square root, cubic root, fourth root, whatnot. If you are multiplying, as long as the index is the same, you can write it together as one radical. And what you do are you multiply the two radicands together. So how cool is this? Let's say I have a cubic root of 2 times a cubic root of 3. What this property says is because this is a cubic root and this is a cubic root, I can write it together as one cubic root. What you do now are you take the radicands. Remember, the radicand is the number underneath the symbol, and you multiply those. So 2 times 3, this can be simplified down to one radical by saying it's the cubic root of 6. Super cool. Now, the other property we're going to look at today is called the quotient property. Now, the quotient property, what it allows us to do, because either of these properties works both ways. If you have a radical over an entire fraction, you can go ahead and take that radical over the top and over the bottom separately. Or if you have a radical on the top and the bottom, as long as it's the same index, I can combine it so it is one radical over a fraction. Okay, so here's an example of that. Let's say I have a cubic root of 1 over 27. I can, because of this property, I can separate this one radical into two. I just have to make sure that I keep the index the same on both the top and the bottom. So I can have the cubic root of 1 over the cubic root of 27. What number times itself 3 times gets you to a 1? Hey, that's a 1, because 1 times 1 times 1 is 1. What number times itself 3 times gets you to 27? And again, there's only one answer because this is an odd index. That ends up being a 3, because 3 times 3 is 9. When you multiply in that third 3, you get 27. So this is what those two properties look like. Today's notes, I promise, are going to be a lot shorter than the last time. I got a little carried away. I missed you guys. I want to teach you everything in one day. So today we're going to go ahead, focus on these two little ideas, and then you will get some practice to do on your own. Okay, so let's go ahead and look at this. Using those properties, I am multiplying. This is a cubic root. This is a cubic root. I can write it together as one cubic root. If you're multiplying, you multiply your radicands together. So 3 times 9. 3 times 9 is 27. Main thing, make sure that you remember this is a cubic root. That 3 stays there the whole time. Now I can go ahead and evaluate it. What number times itself 3 times gets you to 27? That is a 3. Here is our quotient property. I have a fourth root on the top and a fourth root on the bottom. What I can do is I can go ahead and make that a fourth root of the fraction 48 over 3. The reason I'd want to do that is because I can simplify this. 48 divided by 3, guys? 48 divided by 3 is 16. Now I can go ahead and evaluate it. What number times itself 4 times gets you to 16? Oh, make sure you have a positive and a negative, because remember from 7-1, this is an even index. This is a positive number, so there's going to be two options, and that's going to be a 2, because check this out. 2, 2, 2, 2. If I look at it in groups, 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. But I can go negative 2, negative 2, negative 2, negative 2, because negative times a negative, it's still a positive 4. Negative 2 times negative 2 is a positive 4. 4 times 4 gets you to 16. So I would have a positive and a negative 2. Here is another example of the quotient property. This is a square root over a fraction. So I'm allowed to take the square root of the top and the square root of the bottom separately. The square root of 1 is 1. The square root of 9 is 3. And again, Okay, we're going to go ahead and look at the product property one last time. These are square roots. And I do know from working with you guys a little bit before the break, some of you like to put that 2 there. If you want to put that 2 there, go for it. If there's not the number, remember it is a square root. So a square root times a square root, I get to go ahead and write it as a square root. Now I multiply the radicands. 2 times 2 is 4. So what number times itself 2 times gets you to a 4? This is an even number. This is positive. So it's plus or minus 2 because 2 times 2 is 4. And negative 2 times negative 2 is also 4. So these are just basic examples of the product property and the quotient property, how you can go from 2 radicals being multiplied together down to 1. Just remember those properties from 7-1. If you have one symbol or one fraction underneath a radical, it is okay to split it into 2, the same as it's okay to take 2 radicals and go down into 1. Okay, now here, writing them in simplest form. There are times where they're not going to be perfect, meaning there's no number that if I multiply it by itself 3 times, I get to 40. So this is that factor tree process that we worked on a couple times. You did have an example or 2 in 7.1 as well. I need 3 of the same term in order to cross it off. 40 is 4 times 10. 4 is 2 times 2. And just as a reminder, once you use a number, once you break it down, you can't use the 4 anymore because now 4 became 2 times 2. 10 is 2 times 5. So in order to simplify this, I need to be able to cross off 3, whatever that index is. 1, 2, 3 2's, so I get to write a 2. When you write the solution, remember it's a cubic root. The value that could not be crossed off was the 5. So it's 2 times the cubic root of 5. Now number 2, using those properties, I can go ahead, take the cubic root of the top and the cubic root of the bottom separately. What number times itself 3 times gets you to a 1? Well, that's a 1. What number times itself 3 times gets you to an 8? That's a 2. So that goes down to 1/2. Now here, this is that quotient property. Again, we're going to go all the way down to simplest form. I have a cubic root on top and a cubic root on bottom. I can write it as 1 cubic root and take the top value over the bottom. Now what this allows me to do is reduce the fraction. 54 divided by 2 is 27. What number times itself 3 times gets you to 27? 3. 3 times 3 is 9. If you visualize this, 3 times 3 is 9. Well, 9 times 3 gets you to 27. Here is one more example for the day. This is the product property. The 5th root and a 5th root. I'm multiplying them together. So it says I can write this as 1/5 root. You take the 2 radicands and you multiply them. So this is a 5th root of 4 times 8. That's 32. So again, let's say that you did not know that this was a perfect 2. Okay, let's say you did not know 5 times 5 times 5, or sorry, 2 times 2 times 2 times 2 times 2 is 32. 5 2's. You could always do the factor tree, and I'm going to show you what happens if everything crosses off. Okay, so 32, that is 2 times 16. 16 is 4 times 4. And each 4 is 2 times 2. So what I'm left with here, my prime numbers I cannot break down any further, are 2, 2, 2, 2, and 2. I need to be able to cross off a set of 5. I can cross off 1, 2, 3, 4, 5, so I can write a 2. There is nothing left. That's why this symbol crosses off. There's nothing remaining, so your solution would be a 2. So I just wanted to show you that just in case you didn't recognize it and you went ahead and you did this method. It's okay. If everything crosses off, the symbol will not be in your final answer. You won't have that 5th root because there's nothing left underneath. So folks, that's what I have for the beginning of section 7.2. I hope you enjoyed looking at properties of radicals. Go ahead, practice your assignment. Remember, there are those optional Zoom meetings where if things are not making sense, you can log on and we can visit and I will help you out. Hope you're having a great day. Miss you much. See you soon.